Hello, I'm gonna make my 2.2 code run faster, or I'm gonna just do 2.3. So I did try this. So on 2.2 right now, this is a multiple of 10 and 0 seconds, and then if I make this 0.01, 0 seconds. But then I tried a higher thing, like let's say do do do, and then make this 10 again. Runtime, run all. 1 second, 0.01. So you can see it already is at 6 seconds. I'll come back and check on that later. But essentially, I see that if I do a multiple of 1 cent, it may be much more accurate. However, it takes too long. So we're going to use bisection search. I'm not sure if it's the same thing as binary search, but I guess I'll learn. Yep, I've used, I think, Coursera, and they have like the same type of limits. And whenever you try to submit a code and it runs it, without running into a bunch of the same thing. The smallest $0, but can do it. If there was no interest, that can be paid off by monthly payments of one. Wow, that's pretty good. That's good. I just wasn't able to figure this out last time. This is still running. I'm going to continue to let this run. Yep. I'm going to let notifications. So let me continue. This makes sense. So balance equals 5,000. Annual interest rate equals 0.18, and then code block lower bound monthly payment lower bound. Okay, monthly interest rate equals annual interest rate, and then lower bound balance upper bound balance times 1 plus monthly okay, I'm just gonna follow this. I was just confused because I was thinking we could just do it yearly, like 12% of the year, but or 18% per year. But then I realized that this is right because we have to do the balance each time. I think this is right. You have to do it's compounded monthly, so like next month's interest will just go up. Surprisingly, this is running. I might stop it in a bit, but you saw how if it was just $10, it'd finish in like 1 second. Oh, this is to the power of 12. Python to the power of 12. I don't know which one I should raise. think that goes there, and then I multiply it by balance. Let me see if this video does any more.
Okay, so that's for the problem 2. How about...
Well, I mean, my code isn't done, but I just want to make sure this is the right function. I guess I can do it later. Well, it doesn't really go over what bisection search. Let's look it up. Oh, it is the binary search method. So you start from the middle, that way, that way, that way, that way. Nice. Nice. So, where was the average? I'm pretty sure I saw average somewhere. I guess not. Okay, so that's all good. Binary search. Binary search. I'm going to take in parameters. Lower bound. Upper bound. So basically do average equals lower bound plus upper bound equals average divided by 2. And then, not this one. To be balance for I in range of 12. If ITB is greater than 0, if ITB is greater than 0, what does it mean when ITB is greater than 0? Well, it means that the balance is greater than 0, so we didn't successfully do it, which means we need to increase the minimum payment. So then we just have to return binary search equals average round. I'm just doing this so it's realistic payment types. So then lower, then we have to go up. So this becomes average, and then upper bound. Else return average. So let me print binary search lower bound upper bound, and then the runtime run off. Oh, of course. Runtime run off. What's the problem? Cost is not defined. It's the average. Runtime run off. Okay, I'm stopping this. Making this 5,000 again. 451.63, 457.42. Oh, I know what I need to do. If ITB is greater than 0, I need to do this. Else, if ITB is less than negative 10, greater than 10, no. If it's greater than 0, and if it's less than 0, return binary search, but this is lower bound, and this is ouch. Runtime, you know, it's a problem. Elf. It's yep, it's a problem. Okay, and once I'm pretty stuck, let me fix this again before I accidentally submit it like that. Go back here. Figure out what they did.
3, now we're going to use the way why we call it computer science is not.
Right. And then what's this video?
For the bisection search, one of the keys you need to have a low bound and high bound. But since this is the finding out the minimum payment, I guess the minimum payment, the lower bound should be 0. It can be negative, but then you will be taking money out again, right? So 0 is probably as low as possible. What's the high bound? The high bound, I guess, will be the balance plus the interest rate. So let's first decide to give a total balance. Yes, low. That means I need to move the low boundary. So let's see. Means now instead of that higher, 0.01. Yeah, actually it does that. I don't see any other boundary I should change. Okay.
Yeah, I guess I shouldn't round to 2. Let's see if that fixes anything. And then this was like greater than 1 and less than minus 1, or greater than 0.01. Less than minus 0.01. Then don't round. $451.63. So this is just supposed to be faster if I make this that. Yeah. Wow, yeah, that was really fast. And make this 5,000 again. Return. This is when I'm gonna round. 2. Runtime. Run all. 451.63. Really good. Okay, I think I got this video. Too low, go higher. Yep, I'm using these boundaries. Okay. Let me 1 second just go through again. Make sure I understand the whole code. So while true, total count is greater than 50, break. Okay. So you don't want to recurse more than 50 times. Which I don't think I need to necessarily put in that check. Necessarily. Payment, low plus high divided by 2. Right. You're making the payment in I don't know. Okay, and then estimate the remaining balance. I'm doing this. If 0 is less than, if new balance is greater than 0 or less than or equal to 1, our absolute value of high minus low equals 1. The lowest payment is that. Okay. Okay. That makes sense. So basically, I mean, position. So if it's between 0 to 1, if balance is within $1, it's fine. And if the difference between high and low is 1, it's fine. I guess I'm going to do that too. If, where is it? Here. So this will become an L. And then if IT, if, let me just copy this, 0 less than new balance, 0 less than ITB, less than equal to 1, or the value of upper bound minus lower bound equals 1, right? Right? Equals 1, forgot about that. Equals 1, nope, then return round average 2. Okay, and then hopefully this works. Yeah, wait, what? Oh yeah, because I'm fine if it's within $1 off. My balance is within $1 off. So this times 12, 505,419. I mean, yeah. Let me print ITB right here, just so I know. Okay, so I'm 20 cents within, and I'm fine. Underpaying 20 cents, I guess. Now let's see what they charge.
The gain, the high, so for the in general, let me read the price to 0.01. Yeah, actually, so if that's to
yep.
that's okay. Went on 0.5 0.01. Oops, when did I? Actually, that's
So 0.001. .001 millisecond. 0.001. Nope. What was the problem? Something happened. Oh. -1. Why isn't I getting none? I'm guessing it doesn't go past that. Is there a chance that ITB can be between these two? Let me print ITB. And then so ITB is minus 0 points. Maybe that. Yep, that fixes it. So I'm trying to get it within 1 cent. So do this times 12. Wait, how much was it? I'll just do this right here. Print ITB. So about, wow. That's literally 1 cent. If you paid $451.62 every day, you'll be within 1 cent.
Not just to get it done. That's what we want to get it done more in a better way. So the bisection search, the basic.
Okay, for this, you're getting 451.63. I wonder if it's because of this. Again, I'm getting none. Less than 0.0. Okay. This is how you guys do it.
Concept is we need to have a bracket. We need to have a lower bound. We need to have an upper bound, and then we squeeze our boundary to the target. Sorry. So how do we squeeze this? You will have a left and right, and if we target that target, let me run that, and then we are going to use a bisecting that to $1. That should be give the same answer as we found using the number 2, right? So number 2, if we use let's see. Number 2, we found a 552. If we change the precision to $1, we should find exactly the same answer, right? Let's just change that to $1 then we will have exactly the same answer. Otherwise,
does that mean if I change this to
too high, and then
10?
If it's too high, that means our gas. Oh, if the balance is too high, that means we didn't pay enough, and then we move the lower boundary higher. Right? So we move the lower boundary higher. Does that make sense?
Mm-hmm.
If it's too low, if it overpaid, we move the high boundary lower. That seems to make sense. Yeah. So, and one point because in principle, because it's even though we try to look for answer which is within $1, but it still goes to floating point position. Yeah. I mean, practice doesn't change the result, but it doesn't give an input to answer.
Okay, so I think what I did was good enough. What I'm gonna do is that I don't like this right here. 0.02. I just don't like the idea that I'd rather pay more than pay a little less and be charged interest for it at the end of the year, not, be done with it at the end of the year. So therefore, if ITB is less than or equal to 0, then only will I exit and make this if it's greater than 0, that Or I'm gonna try to limit it to 0.01 less than equal to. I'm okay with paying up to a cent more. Okay. It's greater than 0, it's less than 0. Oh, minus. So if it hits 0, it's good. If it's greater than 0, we'll move the upper bound so we pay more. If it's within 1 cent below, it's good. If it's more than 1 cent below, then we lower the lower bound. What this ensures is basically that we're done with the whole thing and we don't pay more than we have to by a cent. So runtime, run all. See, this is half. We pay half a cent more, which I'm fine with that than paying a quarter cent less, because you know they want to get every bit of it, especially credit card companies, that they're not going to care that it's quarter a cent. They're probably still going to round it to where it make you pay the cent or something, or carry it over, and this will just make sure I'm on the safe side. So now let me just copy this over. Runtime on all. Oh, runtime on all. Don't need to print this no more. Okay, this is good. Now what does the result ask for? To the cent. And this finds it to the cent. Still need to try this. That fails. So I can't round it, which is a problem. Let me round up in Python, because another problem that I'm thinking of problem that I'm thinking of is that, let's say that I have a plan on how I'm gonna. So over here, so you see how I was originally rounding this, right? So like, let me run all of this again. 63. This is doing it because it's that. Let me see what happens if I try to do. So 2.395. Okay, so it rounds, nice. 292. So this is the problem. Let's say I need to pay, the minimum is 42.292 in order to actually not have any left over. I can't pay 292, so I'll have to pay 30, but that's not how it works. But I can do times 100 math.ceil divided by 100, and then it's not defined. Do I have to run import math? Okay, I gotta do import math. Let me just do it there. Let me just do it here. So that's why. So yeah. By the way, I'm gonna go back here. I just realized I don't need to round it anymore. But I'm not gonna change it now because I already recorded the webcast for it and I didn't realize it then. But this is basically unnecessary because format does round it. I thought it just cuts it off, right? But does round. So this is unnecessary, but I'm not going to change it now because I already recorded the webcast for this as this with the rounding. But here I can just leave this like that. And what do I do here? I just take the binary search, lower bound, upper bound, and then runtime run all. Okay, this basically rounds up to the nearest cent rather than rounding down if by any chance it was less than 5. So let me start doing commenting and I'll go ahead and submit this. Input parameters, intermediary variables, binary search function. No, just kidding. I want text. Code. Calculate middle point. Set to balance for each month. If remaining balance is within 1 cent overpaid. If a balance is left, pay more. If you will overpay more than a cent, pay less. And I think this function works. Import math library. Print the lowest payment to rounding up the cent value. Time run all. I think this is all good. I guess I'll go ahead and upload and share this video. And again, like I just said, I understand this is unnecessary, but I'm just gonna keep it here and I'll comment on it on my submission doc. Thank you.